Good morning, all. Am I audible? Please let me know. Okay, fine. Let us start the session. I don't want to waste the time. Last class, what we saw, see, we are discussing about multivibrators. And in the last class, we had been discussed about the basic fundamental properties of a stable multivibrator, right? That is called a stable multivibrator, right? The another name for a stable multivibrator is called, we can also call it as symmetrical circuit, and it is also called what? Square wave generator, right? Because multivibrator will generate square waves, right? And the both states, right? What I can say, on state and off states are positive spike, negative spike, both are not under our control, right? So simply unstable multivibrators are simply called what? Square wave generator. Just to remember like that, that is enough, right? Okay, now we have to discuss few more things, because in the last class we had been discussed about everything, right? That is, we have seen the characteristics and the waveform, everything I have drawn, and we made finalized conclusion. We saw symmetrical circuit also, right? And we have seen, right, how its waveform it's look like, and we have seen the hysteresis characteristics, and we saw how to calculate the hysteresis with everything, that is hysteresis voltage, right? Everything we saw, right? Now we saw a formula to calculate the value of time period t. I hope you all have remember, right? What we had been discussed at last, I had been defined a certain formula to calculate the value of time period t. Now your target is, we have to achieve the value of time period t with the help of what? RC circuits, right? Yes. Anyway, finally what we saw the formula is what? T is equal to RC into ln of 1 plus beta upon 1 minus beta. Am I correct? Yes, this is the formula that we saw. But here, if you observe the waveform of a stable multivibrator, it's a square wave generator, right? It's a square wave generator. It's keep on generating the waveforms like this. Whereas I had been considered only one positive cycle, right? Here only we had been observed the property of capacitor, and I did not consider the second cycle. If you see, this is the complete waveform of your square generator. This is the complete period of the signal. Do you guys agree with me? Yes. So let me call this time period as t1, right? This is a time period t1. We went up to what? This point, right? We just went up with this point, right? And its correspondent voltage. There we saw there are two voltages. Listen guys, this is the voltage that we are getting from the input side. Input side means capacitor had been placed across or has been connected with the what? Inverting terminal. That is the input side of the operational amplifier. Whereas this state is called what? This is the output side. This is the output side. This is what? Maximum input available voltage. That is maximum available input voltage across the capacitor or across the inverting terminal. And we saw this voltage will be equal to plus beta times of Vsat. And this voltage will be equal to what? Plus Vsat. And if you observe in the negative waveform, same thing, but negatively it is called minus beta times of Vsat from the input side available voltage, right? And this is called what? Minus Vsat, output voltage. Are you guys are getting me? This is square wave that we are receiving in the output side. Of course, it is called square wave generator. A stable multivibrator is also called what? Square wave generator, right? And here the input side maximum applied voltage is either it might be plus Vsat or it might be minus beta times of Vsat. That is plus beta times of Vsat or it might be minus beta times of Vsat. Do you guys agree with me? See that this is the maximum available voltage across the capacitor or across the inverting terminal or across the input of the operational amplifier, and then this voltage is being compared with the output. Output means this Vsat. This Vsat will be appeared, right? Output some portion will be appeared across the non-inverting terminal, and then we are making the comparisons at all. That things already we have concluded. Now the conclusion is, these voltages are called supply voltage. Of course, guys, we have not connect our unstable multivibrator with some external circuits. I already told you. I did not told like that, right? But from the input side, we did not. I'm not talking about external supply. I'm talking about the input voltage, right? Capacitor is acting as a source and it is supplying some voltage. Due to charging and discharging action of the capacitor, there was some voltage. It's keep on being injected across the inverting terminal, right? I'm talking that percent, that is called supply voltage, right? So the supply voltage in your examination you will be requested to calculate the value of supply voltage of the astable multivibrator. It means, don't think sir that since I was discussing about astable multivibrator from the beginning but I have not seen any type of external supply sir, so it is zero. Don't make blunder mistakes like that. If you are requested to calculate the value of supply voltage, that is nothing but either it may be plus or minus beta times of Vsat. Clear? That is the supply voltage. And the output voltage is simply called quasi state output voltage, right? So we are calling it as quasi. You choose the meaning of this one in your free time, right? Quasi state supply voltage, that is quasi state output. This is called what? Quasi state output. In your examination, once again you are requested to calculate the quasi state output of the astable multivibrator, right? Now quasi state output, either it might be what? Plus Vsat or it might be minus Vsat. So quasi state output is what? Plus or minus Vsat. That is the next conclusion. Now coming back, this beta, that is feedback factor, and we also know how to calculate this beta. That should be equal to what? R2 upon R1 plus R2. Just we can substitute those two values also, right? And the next thing, I told you this is only first half cycle. If I will repeat the same procedure in the second half cycle, you will come up with the same answer. Actually, I thought I had given this work to you, right? You please, I hope many of you guys completed, but if you have not completed, take the same procedure, whichever the things that I have done in the first half, repeat the same procedure in the second half, you will come up with the same answer. There was no changes in your answer. So T2 also going to be same as T1, that is RC times of ln of 1 plus beta upon 1 minus beta. Fine sir, then what is the total time period? Then the total time period is going to be T1 plus T2. But if you observe, the time period T1 and T2 both are remain same. So the total time period is going to be twice of RC into ln of, I can say, 1 plus beta upon 1 minus beta. Clear? So this is the total time period of your astable multivibrator. From this you can also estimate the value of frequency by taking reciprocal for your time period. This is going to be output frequency. Clear? Yes, I hope you guys are getting me, right? So we have understood many things about what? Astable multivibrator, right? So astable multivibrator is also called what? Square wave generator. It has two states. One is output state, another one is what I can say is quasi state output, another one is what? Supply, input supply, right? So in the input supply, the available voltage is plus or minus beta times of Vsat, and in the output side, the available voltage is what? Plus or minus Vsat. This is beta times of Vsat, that is Vsat. Okay. Next, what will be the duty cycle? Can you please tell me? Duty cycle in the sense, we all know, right? Duty cycle in the sense, let me define, right? Already we had been observed this duty cycle in power electronic circuits, in analog electronics also I was discussing about for diode we can define the duty cycles. In digital electronics we saw the duty cycle, right? So let me repeat that term once again. Duty cycle D, or some people are using delta, right? It depends, right? Okay, fine. So this duty cycle can be defined as what? We all know that is working time period upon total time period, and that is simply we are calling it as on state. Right? Now if you observe our circuit, see there, let me call, for example, my capacitor is working. Let us consider charging period, right? Or you can also consider the output waveform, right? See, this state is called off state because negative voltage. We also know, right? What do you mean by on state? There are two states in our circuits. One is called on state and another one is called off state. Right? Now, actually, this duty cycle can be controlled with the help of diodes, because we know diodes will work in forward bias and it won't work in reverse bias. Of course, it will also work in reverse bias, but that bias is called what? Open circuit bias, because in reverse bias your diode won't respond. It means it will behave as an open circuit. Right? So that state is called off state, right? So duty cycle of your stable multivibrator can be controlled or it can be variable, right? By connecting a diode with the capacitor, right? Because there is a person is called charging and discharging. That person is called, there is a person is called a capacitor. He is doing two actions. One is called charging and discharging. That action can be controlled by connecting a diode with the capacitor, because capacitor will going to produce the time period. How do we calculate? That is, how did I calculate the value of time periods? we all know we made this value, right? We made it possible with the help of what? Charging and discharging time period of the capacitor. So if I'll change the charging and discharging time period of the capacitor, automatically what will happen? It will also change the duty cycle of the circuit, right? So in unstable multivibrators, in any circuits, right, if you want to change the time period of the circuit just by connecting the diode with the capacitor, because diode is the capacitor is the person who is taking responsibility for the production of the time period in the output side. If I will change the capacitor charging and discharging time period, automatically it will change the entire output time period also. So this time period can be controlled by capacitor. That capacitor charging and discharging properties can be controlled by diode. So indirectly I can say duty cycle of the circuit can be controlled with the help of diode, right? Now if you observe the output, see that 50% will be in on state, 50% will be in off state. Are you guys are getting me? This is the total time period. Positive side and negative side both are equal. Positive side I am simply considering it as on state. So that is going to be what? Let me consider. That is going to be on state. For an example, if I will consider only T1, then the total time period is what? T1 plus T2. But what we know, T1 and T2 are equal. T1 and T2 are equal. So the total time period will become T1 plus T2. But I can say that is twice of T1. Let me repeat. Actually, T can be written as T on is nothing but T1 on state. Right, the total time period is T1 plus T2, but T1 T2 both are equal. If I will replace T2 by T1, then T1 plus T2 will become twice of T1, such that T1 getting cancelled out. So the duty cycle will become 1 by 2, or we can say 0.5 in percentage. If I will multiply it by 100, then automatically it will become 50%. So duty cycle of your square wave generator or a stable multivibrator is 50%. Clear? So these are all about your unstable multivibrator. Let us immediately discuss about the second person, is often called what? Monostable multivibrator, right? So in monostable multivibrator also we have once again two states, right? So let us discuss about those states, right? One is called standard output state and another one is called quasi state. See, first of all, quasi state means the state is being changed, right? It is being changed, right? And it will be changed in the sense or a particular time period enna change aita anga irundha thirumbo enna it is getting back to normal state, right? Output state is going to be stable state. Quasi state in the sense the output is not stable, it is keep on changing. We cannot define it is always stable output அப்படின்ற term நம்ம define பண்ண முடியாது. See there, supply voltage is called stable input. See, it is always being fixed in between what I can say plus, either it might be plus beta we set or it might be what plus minus beta we set, right? Of course the thing is quasi state means wherever your state is keep on changing. இப்போ input side லயுமே வந்து நம்ம இந்த beta v set வந்து continuously வந்து what I can say fixed வந்து maintain பண்ண போறது இல்ல, right? So we can also call, right, so it can also be called quasi input supply voltage. This is called what? Quasi output supply, output state voltage, right? What is the difference? Quasi means the state is keep on changing, right? Okay, fine. The conclusion is, in case of unstable multivibrator, one thing I would like to conclude, both input and output states are called quasi state only, but in the output side this is plus or minus v set is going to be the quasi state output. Input side plus or minus beta times of v set is going to be quasi state input, right? But in the examination you will be tested for supply voltage only, right? Anyway, just to make a note of it, that is enough. Then what do you mean by stable state? Let me conclude. From the input side, if the applied voltage will be stable. Sir, what do you mean by stable? Stable means either it might be permanently fixed as plus beta v set or it might be permanently fixed as minus beta v set. That is called a stable input state. Similarly, output is going to be stable output when its output is permanently fixed. Either it might be plus v set or minus v set, but it is not allowed to change its output. For example, if it is permanently being treated as a plus v set, then that is called a stable output because it is like a DC waveform. There was no changes. Right? If it is permanently fixed as minus v set, again it is called what? Stable state, because there is no changes in the output, right? Yes. So that is the difference between stable and quasi stable, right? I hope you guys are getting me. So let us discuss about monostable multivibrator, right? Wait one second, let me remove these things. I think in the last class at the end I had been discussed about monostable multivibrator, right? I had just given the waveform, but I had not explained the operation. I was requesting you to understand the basics of monostable multivibrator, right? See, there was no big difference between unstable multivibrator and monostable multivibrator. Just by doing some modifications in the unstable multivibrator, we can bring monostable multivibrator, right? So let me design monostable multivibrator also. Let's understand the beauty of monostable multivibrators. Let us discuss about monostable multivibrators. Okay, yes, what we saw, sir, already we had been discussed about a stable multivibrator. Yes, sir. It has two terminal from the input side. One is inverting terminal and another one is non-inverting terminal. And we saw this non-inverting terminal had been connected with our feedback line, that is in output line. There we kept some resistance value. They are calling it as feedback factors, right? And I am connecting it with the ground. And this is going to be the output voltage V0. Right, and we saw at this point what is the amount of voltage that is entering. We all know current taken by the operation amplifier is going to be 0 ampere. So the voltage across the inverting terminal, sorry, non-inverting terminal is going to be, it can be considered as voltage drop across the resistor R2. So R2 upon R1 plus R2 into output voltage V0 is going to be the voltage drop across the non-inverting terminal, and R2 by R1 plus R2 can be simply treated as beta times of output voltage, whereas that output voltage V0 might be plus Vset or minus Vset. So later we will discuss about that things, right? So these things already I had been concluded in what, a stable multivibrator also, right? Now let us coming back to the another terminal, that is called inverting terminal. There also we are going to connect some persons. Let me connect them. Already we have done that operations at all. Anyway, let me repeat, right? So here we have some resistors, some resistant, right? And then here let me connect two persons. One is capacitor and another one plate is, there are two plates for a capacitor. One plate is connected with the inverting terminal, another plate is connected with the ground, right? Now in across with this capacitor I am going to connect a diode, right? So that is what our next task. Now simply by connecting this diode, what we are going to do, right? So simply by connecting, one second. Okay, now with the help of this diode, what we are going to do, that is we have to understand, right? So let us see, that is the capacitor and this is going to be your diode. And apart from that, I told you I made some arrangements across the non-inverting terminal, right? So let us discuss about that one also. Here I am going to consider some capacitor with some resistor circuits, and then output of this circuit will be connected across the diode, right? Yes, there is one more diode, and this output is directly connected with this output, right? One second, yeah, this is going to be the output, right? That's all, it is coming back. Fine, sir. So this is going to be the another one capacitor. Let me call it as C1 and C2 resistor R, right? So let me define that is feedback resistor. It's much better. Yeah, let us go like this. And here we are going to apply some voltages. That's enough, right? Yeah, square wave only. There is no doubts. Okay, sir. Now coming back, what we are going to do with this, right? This is square wave, guys. I have to give priority for this one. Fine, this is much better. Okay, now coming back, here also we have some diodes. Let me call it as D2 and diode D1, right? So actually what we are going to do with this circuit, this is simply called monostable multivibrator. Why it is called monostable? Let us see. First of all, let me remove this portion. Let us assume there was no such type of arrangements that was being connected with our operation amplifier, right? That is our circuit. Now you please tell me what is the output. Let us see. Suppose I know there are two possible states are there in the output side. Either it might be plus Vset or it might be minus Vset, because since we are discussing about the non-linear application of the operation amplifier, in non-linear applications what we simply saw, operational amplifier was forced to operate in the state of saturation zone, right? There are two states for our operation amplifier. One is linear zone. In linear zone, output of the operation amplifier is directly linked with the input voltage Vn, whereas in case of non-linear applications, output of the operation amplifier, though it is depending on the input states, its output voltage lies in the boundary means what? Plus or minus saturation voltage, maximum voltage, right? So either your output might be plus Vsat or it might be minus Vsat. Okay, yes, that things at all we know. Let us discuss about the output. First case, let me assume the output of the operational amplifier is plus Vsat. Suppose if the output of the operation amplifier is plus Vset, now you please tell me, is there any chances, is there any possibilities to change the state of your output? If it is plus Vset, let us simply observe the operation. If it is plus Vset, then we all know this output V0 can be replaced by plus Vset here. Yes. This is the available voltage across the supply, that is input side, across the non-inverting terminal. That voltage is going to be enter across the inverting, that is non-inverting terminal. So I can say plus Vset will going to be the plus beta times of Vset will going to, that is the amount of voltage that is being injected across the non-inverting terminal. And let us assume, since there was no energy across the capacitor, we are in the initial state, that is the first time I am going to purchase this monostable multivibrator from the market, right? Okay, now I just connect this circuit. See, what is the purpose of this monostable multivibrator? It will simply act as a timer, right? There are many type of timers are there. We can design the timer circuits with the help of 555 circuit, that is 555 timer will be there, right? Voltage crystal oscillators are there, right? So this is also one more type, right? Emitter coupled, right? With the help of transistors, BJT configurations also, we can design this, what I can say, timer circuits, right? Anyway, this is also the best person who is acting as a timer, right? We will see the observation later. I will collect this, why it is called a timer. I will explain these things at last. First, let us understand. I told you, if the output is plus beta, we said, then how this circuit will behave. Let us see. When this output is plus beta, we said, then across the non-inverting terminal, positive voltage will be reflected. Yes, sir. At the same time, this positive voltage will drive some current here, but that current cannot enter into the operation amplifier, since the input resistance offered by the operation amplifier is very high. Ideally, I am speaking, it is infinity. So current was no entering. There is no chances of entering the current into the operation amplifier, since it was being assumed to be 0 ampere. Okay, so the current that we are getting from, see there, current will always flow from higher potential point to lower potential point. Since output is plus V side, we have high positive voltage, whereas in the input side, since there was no energy across the capacitor, so directly I have zero voltage here. There was no any voltages to oppose the output voltage, right? So automatically current will start flowing from the output point. Yes, sir. Now the question is, your current is slowly coming here, and then it is looking, there are two people, right? Which path is having least impedance, right, to reach the ground? Current will always choose low impedance path, right? Okay, sir. Since, let me assume this diode is ideal 1. Let us assume the diode is ideal 1. Of course, we can also consider the practical diode, and I can consider that small voltage drop 0.7, but I don't want to consider that. Let us understand the beauty, right? Suppose if the diode is ideal 1, then we can simply say, when we are starting this monostable multivibrator with the possible output as plus V set, then this positive voltage will going to be simply reflected across this port. Here we have 0 voltage. When your anode voltage will become greater than cathode voltage, see there, here I have positive voltage at this junction, here I have 0 voltage. Now you please tell me, which person will turn on immediately? Diode will turn on. Yes, so this diode, across the anode voltage we are injecting positive voltage, across the cathode I have 0 voltage, so diode will immediately turn on. Why? Because whenever the voltage across the anode will become greater than the value of voltage across the cathode, that is the condition to turn on the diode. Yes, our condition is being simply, that is satisfied simply, so definitely this diode will turn on and it will be short circuited. If it is short circuit, then what will happen? Sir, if it is short circuit, current will always choose low impedance path. So the entire current that is coming from the operation amplifier output, it is simply started diverting through the diode. Now you please tell me, is there any chance for your capacitor to charge? No. Your capacitor won't be charged. Why, sir? Because there was no energy. Who is going to provide the charge? Charge means Q, right? If you want to charge your capacitor, then charge has to enter into the capacitor. Charge Q has to enter into the capacitor. But since capacitor had been connected in across, right? There was a short circuit across the capacitor. So current will always choose low impedance path. So the entire current is started diverting through the short circuit line. Your capacitor won't be charged at any cost. Okay, sir. Now you please tell me, if it is short circuited, then what is the voltage at this point? 0 voltage. Do you guys agree with me? When this diode is getting short circuited, see there, in short circuit we have what? 0 voltage. This 0 voltage will be reflected here. That 0 voltage will be reflected across the inverting terminal. Now you please tell me, what is the available voltage across the non-inverting terminal? Across the non-inverting terminal, I have some portion of output voltage, that is positive voltage. So across the non-inverting terminal, I have some positive voltage. Across the inverting terminal, I have 0 voltage. When the voltage across the non-inverting terminal, will become greater than the voltage across the inverting terminal. Across the non-inverting terminal, I have plus beta times of V set. Across the inverting terminal, I have 0 voltage. Now, across the non-inverting terminal, voltage is greater than across the inverting terminal voltage. So, automatically, output of the operation amplifier will be fixed as plus V set. Do you guys agree with me? Yes, sir. right? So what is the conclusion here? This voltage will be permanently fixed. See, in the state adukapra eppadi inga change agum? Is there any chances? No. So if you are drawing the output waveform, if you want to draw the output waveform, we can simply draw with respect to time period, the output is permanently fixed as plus beta v, sorry, plus v set. There was no changes in the circuit. Okay, sir. Now the question is, this state is called stable output state. Let me call this state is called what? Stable output. Guys, why I am calling it a stable output? Why? Because there was no quasi state. Quasi state means state of this circuit in the output side or input side has to change. Is there any changes? No, it is permanently fixed as stable state, right? But if you want to produce quasi state, yes, it could be possible. How? That could be possible with the help of negative spike producer. Clear? Let us see how this circuit will going to help us to produce, to get this timer output, right? To treat, how will you design this timer operation from this, what I can say, monostable multivibrator, right? Yes, there is only one state in the output, that is called a positive output state, right? So that state is fixed permanently in the output side. If you want to produce the quasi, that could be possible with the help of spiker, negative spike producer, right? Let us see what I'm going to do. Let me join this point here. Let me connect this spike here. Okay, now listen one thing, we are not going to permanently connect this negative spiker with this circuit, right? Whenever there is a need of timer, right? இப்போ டைமர் அப்படின்னா இப்போ நீங்கள் சிம்பிளாக அப்சர்வ் பண்ணி பாருங்க, இந்த அத்லெட்டிக்ஸ் மேரத்தான் பிளேயர்ஸ்லாம் வந்து அதாவது காம்படிஷனில் இருக்கும்போது கண்டக்ட் பண்ணுவாங்க இல்லையா, அந்த அத்லெட்டிக்ஸ் கேம் வந்து கண்டக்ட் பண்ணும்போது தெர் இஸ் அ டைமர், ரைட்? நம்ம எல்லாருக்குமே தெரியும். அந்த டைமர் வந்து என்ன பண்ணும் அப்படின்னா, இட் வில் ஜஸ்ட் கவுண்ட் தி வேல்யூ, சம் கவுண்டர்ஸ் ஆர் தேர். ஃபார் எக்ஸாம்பிள், இப்போ வந்து 60 செகண்ட்ஸில் வந்து நம்ம வந்து முடிக்கணும் அப்படின்னா கவுண்ட் டவுன் வில் ஸ்டார்ட் ஃப்ரம் 60 and it will be keep on reducing, 60, 59, 57, keep on 40, 30, 20, 10, 5, 4, 3, 2, 1, 0, right? 60 seconds, right? Counter will count down. That is the let me call it as a down counter. We can call this one as what? Down counter, right? But down counter அப்படினா அந்த counting எப்படி இருக்கும்? It is counting from 60 to 0, right? Yes, that is simply called a timer application. இப்போ இங்க என்ன பண்ண போறோம் அப்படினா, we are going to இந்த சர்க்யூட்டோட ஸ்டேட்டை வந்து நம்ம சேஞ்ச் பண்ண போறோம் from positive to negative. அப்ப டக்குன்னு ஒரு ஸ்பைக்கை ப்ரொடியூஸ் பண்ணும்போது நான் என்ன ஆகும் அப்படினா, immediately output of the circuit will be changed from plus beta v set to minus beta v set. நீங்க டைமரை செட் பண்றீங்க இல்லையா, அப்ப என்ன ஆகும்னா இனிஷியலா 0 ஸ்டேட்ல இருக்கு, 0னா ஸ்டேபிள் ஸ்டேட். அப்ப டக்குன்னு அதை கிளிக் பண்ணும்போது, ஃபார் எக்ஸாம்பிள் நான் 1 minute வந்து செட் பண்றேன் அப்படின்னா அது என்ன ஆகும்னா 60 செகண்ட்ஸ்ல செட் ஆகும். அப்ப டக்குன்னு என்ன ஆகும்னா இந்த 0 ஸ்டேட்ல இருந்து பாசிட்டிவ் ஸ்டேட்ல இருந்து நெகட்டிவ்க்கு போய்டும், கவுண்டர்ல வந்து 60 அப்படின்ற டைம் வந்து செட் ஆயிடும். இப்போ கவுண்டர் என்ன பண்ணா 60ல இருந்து அப்படியே ரெடியூஸ் ஃபாஸ்டா ரெடியூஸ் பண்ணிட்டே வந்து ஒரு பர்టిక్యులர் டைமுக்கு அப்புறம் again it is getting back to the normal state. அந்த 60ல இருந்து 0க்கு வருது பாத்தீங்களா, that is the time period where we are producing the action of timer. Getting me? Because it is trying to getting back to the original state. It is bumping its states to, that is, it will try to recover its original state when we are changing the property of the circuit with the help of negative spiker. So whenever there is a need of timer application, we have to inject some spike. நீங்க click பண்றீங்க வெளியில இருந்து, that is called negative spike injection. We are triggering the circuit action such that it will produce, it will goes to quasi stable state, that is quasi state. Again, within a practical, that is a certain time period. That time period will be defined by us, right? Capacitor இருக்கு, resistor இருக்கு. By changing the proper value, by keeping the proper value of your resistor and capacitor, we can change the time period such that a perfect quasi state could be possible. Whichever, if you want to fix 2 minutes or 3 minutes, 4 minutes, whichever the time that you want, you can fix it. Okay, fine. So let us see how to produce that quasi state with the help of monostable multivibrator, right? This state is fixed. Let me understand. See, sorry, let you guys understand here. This state is fixed. I'm not going to change this state, but I want only ஒரு பர்టిక్యులர் டைம் பீரியடுக்கு மட்டும் நான் ஸ்டேட்டை சேஞ்ச் பண்ண போறேன். நீங்க சேஞ்ச் பண்றது மட்டும் உங்களோட வேலை. பிளஸ் வி செட்ல இருந்து மைனஸ் வி செட் கொண்டு போறது மட்டும் தான் உங்களோட வேலை. அது திரும்ப அதுவே நார்மல் ஸ்டேட்டுக்கு வந்துரும். அது எப்படி சார்? லெட்ஸ் see. பாருங்க, ரைட்? இப்போ நான் என்ன பண்ண போறேன்னா, see, first of all, let me clip, that is, let me cut this gap diode from the circuit. You please observe, this is the point where we are going to receive the output voltage. And then this voltage will going to be the input. I cannot let me call output or cathode voltage, because that is the voltage it is being injected across the diode, right? Okay, first of all, இப்போ இந்த சர்க்யூட் மட்டும் அப்சர்வ் பண்ணுங்க. ஒரு ஆர்சி சர்க்யூட் இருக்கு, ஒரு கெப்பாசிட்டர் இருக்கு, ஒரு ரெசிஸ்டர் இருக்கு. இது யாருங்க? ஹூஸ் திஸ்? This circuit is simply called differentiator, right? I hope you all guys remember these things, right? that is called a differentiator, right? This is RC circuit, this is called what? Differentiator, right? In RC circuit, if you are measuring the voltage across the capacitor, then that is called low pass filter. If you are measuring the voltage across the resistor, then that is called high pass filter. By giving the input voltage, if I will measure the voltage across the capacitor, then that is called low pass filter. If I will measure the voltage across the resistor, then that is called high pass filter. High pass filter can also be considered as differentiator. I hope you all remember. Low pass filter can also be considered as integrator. That integrator means we had been discussed about controller circuits and what I can say compensators, right? So integrator will be equal to what? Lag compensator. Differentiator will be equal to what? Lead compensator. I hope you all remember, right? Yes. So that is also equal to what? In controller we saw proportional integral controller, proportional derivative controller. Differentiator will be equal to proportional derivative controller. Integrator will be equal to what? Proportional integral controller, right? Yes. That actions already we had been concluded everything. So see there, this is simply acting as a differentiator. So what this differentiator will do? See there, since we are passing a square wave into the differentiator. Now what is the purpose of differentiator? It will differentiate the input, right? If it's differentiate the input, then already we have a square wave. Let us assume if I have a step waveform, what is the differentiator value of step? Step differentiate panna enanga varum? Of course we are getting impulse. Yes or no? Yes. So then what will happen? That square will become a spike now. It will be converted as a spike waveform, right? Because it will become an impulse. Right? So output of this differentiator will be like this, right? Positive spike, and then you will have negative spike, and then you will have positive spike, and then again you will have negative spike. It will be keep on continuous, right? Because it is acting as a differentiator. Guys, I hope you all remember what I had taught already. We saw in control system what I taught you. If we have a impulse signal, right, integration of impulse action will give you what? Step. Correct? Step is nothing but square. Again, step integrate panna you are going to get ramp. Integration of ramp will give you what? Parabolic. Now, differentiation of parabolic will give you what? Again ramp. Differentiation of ramp will give you what? Step. Differentiation of step will give you what? Impulse. Okay, drag delta function. Already we had been concluded all these things, right? Yes, I don't want to waste my time. Coming back. Okay, sir, when we are passing this spike output to the diode, what will happen? Diode, and see there, since this diode connected in reverse bias. Correct? See there, if in the diode on the positive spike across cathode inject diode open circuit. Why? Because this diode will turn on whenever the voltage across the anode will become greater than the voltage across the cathode. When we are injecting more positive voltage across the cathode, diode won't respond. Why? Because let us assume initially there was no anode voltage directly here. I cannot say, right? So the thing is, let us assume here I have 0 voltage. Here I am going to inject positive voltage first. By default, if it is positive, opposite is 0. If it is negative, opposite is positive. That's all, right? Or you can simply take like this. If it is plus, then if it is one pakkam positive, another pakkam minus, negative, like that, right? You can take like this. See there, when we are injecting, simply understand, when we are injecting anode across நம்ம எந்த ஒரு supply inject பண்ணல. இப்போ நம்ம cathode மட்டும் தான் focus பண்ணிருக்கோம். அப்ப anodeல யாருமே இல்ல அப்படினா we can take 0 voltage அவ்வளவுதான், right? So when we are injecting more positive voltage across the cathode, diode will be short circuit. Diode will be open circuit, so it won't allow any positive spikes. It will be blacked by diode. Then which type of waveform it will produce? When we are injecting more negative voltage across the cathode, since anode does not being connected with any kind of external mechanism or supply, so voltage across the anode will be 0 voltage. Voltage across the cathode, when we are injecting negative spike means negative voltage. So cathode negative voltage, anode positive voltage. 0 voltage அப்படிங்கிறது greater than negative. Do you guys agree with me? Across the anode I have 0 voltage, but across the cathode I am injecting negative voltage, sir. Negative potential value is always less than 0, sir. So anode voltage is greater than cathode voltage. Diode will turn on and it will allow these negative spikes to the what? Oscillator, right? So at this point, right, up in output of the diode is going to be what? Output of the diode is, it will produce negative spike. Negative spike only it will produce. Keep on. Continuous produce பண்ணாது. நான் ஏற்கனவே சொல்லிருந்தேன். Based on our application, only one spike I am going to inject. திரும்ப உங்களுக்கு எப்ப spike வேணுமோ அப்ப நீங்க திரும்ப inject பண்ணிக்கலாம். It's like a triggering circuit. Okay, fine, sir. Now what we are going to do with this? Okay, I hope you guys are getting me. Let me rub all these things simply. Let me redraw, right? Let us coming back to the original state, right? So simply now I can say across this point we are injecting negative spike. That's all. Across this point we are injecting negative spike. It is going to be the input, but it is not continuously being injected, guys. You have to understand, only one spike is going to be injected right now. We are injecting negative spike. Now we know the operation. Okay sir, now இப்போ நீங்க டக்குன்னு வந்து ஒரு நெகட்டிவ் ஸ்பைக்கை வந்து இந்த இடத்துல இன்ஜெக்ட் பண்ணதால என்ன நடக்கும்? வெரி சிம்பிள், வெரி வெரி சிம்பிள். லிசன் கைஸ், இங்க என்ன வோல்டேஜ் இருக்கு? பிளஸ் பீட்டா வி செட் இருக்கா? இப்போ இந்த பிளஸ் பீட்டா வி செட் டக்குன்னு நீங்க வந்து ஒரு நெகட்டிவ் வோல்டேஜ், ஃபார் எக்ஸாம்பிள் -1 வோல்டேஜ் இங்க இருந்து வருதுன்னு வச்சுக்கோங்களேன். இந்த -1 வோல்டேஜால இந்த பிளஸ் பீட்டா வி செட்டை மல்டிபிள் பண்றீங்க. இந்த பாயிண்ட்ல ஆல்ரெடி அவைலபிள் வோல்டேஜ் என்ன? பிளஸ் பீட்டா வி செட். அப்ப இமிடியேட்டா இந்த வோல்டேஜ் வெளியில இருந்து டக்குன்னு ஒரு நெகட்டிவ் வோல்டேஜ் வந்து மல்டிபிள் பண்ணா என்னங்க மாறும்? இதோட ப்ராப்பர்ட்டி கம்ப்ளீட்டா சேஞ்ச் ஆகுமா ஆகாதா? Definitely it will change. When this beta V set is getting suddenly multiplied by -1 voltage, automatically immediately it will be changed as minus beta V set, and then this spike will gone. See there, a small spike with a -1 voltage, immediately it will be injected and it will gone. Then because of that sudden change, what will happen? This plus beta V set immediately changing itself as minus beta V set. Sir, what will happen, sir? Here already what is the permanently available voltage here? 0, sir. Here minus beta V set. So what I have done, simply I was injecting a small amount of negative voltage across the non-inverting terminal. Because of that, it is going to be multiplied with the available voltage. So the available voltage across the non-inverting terminal immediately changes as minus beta V set. Immediate action, all are immediate. டக்கு நடக்கும், right? So இப்போ இங்க நெகட்டிவா மாறணும்னு இங்க என்ன ஆகும் அப்படினா, just observe, sir. Here we have 0 voltage, here we have minus beta V set. When the voltage across the inverting terminal will become greater than the value of voltage across the non-inverting terminal, output of the operation amplifier will be changed or not? Yes, sir. Yes. So what is the available voltage right now? Plus V set. Now because of this change, now minus V set, inverting terminal voltage will become greater than non-inverting terminal voltage. So automatically output state of the circuit will be immediately changed to the quasi state, and then for a particular time period it will be it will be what I can say remains constant, and then it is getting back to the normal state or stable state. And then your output won't be changed. திரும்ப என்னடா நீங்க வந்து என்ன பண்ணிட்டீங்கன்னா ஸ்டேட் வந்து மாத்திட்டீங்க, மைனஸ் பி செட்டுக்கு நீங்க மாத்திருக்கீங்க, பட் இட் இஸ் நாட் பர்மனன்ட். I told you a timer. இப்போ ஒரு நீங்க 0 செகண்ட் ஃபார் 60 செகண்ட்ஸ் 1 மினிட் செட் பண்ணி நீங்க கிளாக் வந்து செட் பண்றீங்கன்னா 60 செகண்ட்ஸ்ல இங்க வந்துரும் டக்குன்னு. அப்ப என்ன ஆகும்? 60 அப்படியே குறைய ஆரம்பிக்கல, 55, 50, 40, 30, 20, 0. திரும்ப என்ன வரும்? எப்ப 0 வருதோ அப்ப திரும்ப again it is getting back to the normal state. Again whenever you want, திரும்ப வந்து உங்களுக்கு quasi state வேணும் அப்படினா you can apply the negative spike once again, and then you can produce that quasi state. Clear? So only this state is called quasi state. This is the time period. This is called quasi state, right? Now let us see under this situation what will happen inside this circuit, right? So this is the point where your capacitor is started charging. Guys, listen, let us see. Sir, now the available voltage in the output side is minus V set. Okay, sir. Now this minus V set. Now what will happen? See there. Now what will happen? Your diode is getting open circuit or not? Why, sir? The available voltage is negative now. If it is negative, then since we have a diode like this, across the anode we are injecting negative voltage, across the cathode we have 0 voltage, so this diode is getting open circuited. Then what will happen? Your capacitor is started charging. But what is the direction of charging? What is the polarity of your capacitor? First thing we also know, sir, current will always flow from higher potential point to lower potential point. What is the available voltage in the output side? Negative voltage. Now if you observe, let me remove this line completely because capacitor is open circuit. I have a simple capacitor here, and see there, here I have 0 voltage, here I have minus voltage. Current will always flow from higher potential point to lower potential point. Since 0 is greater than minus V set, so current will flow like this. This is the direction of your current. For your capacitor is a passive element, sir. For a passive element, current entering point plus leaving point is minus, such that capacitors keep on charging up to what? Let us see. Initially, let us assume initially there was no energy across the capacitor. Till now your capacitor had not been charged yet, right? Okay, sir, there was no energy. இது வரைக்கும் capacitor charge இல்ல. But now if you observe carefully, guys, carefully observe. See there, your capacitor is charging negatively. It is not positive charge. In the negative off cycle we are charging the capacitor, right? So your capacitor is keep on started charging negatively up to what? We know capacitor can charge up to the final value of minus V set. It can go, right? Whereas final value of the capacitor is minus V set only, but we are not allowing the capacitor to go up to the final value. Your capacitor voltage will be restricted up to minus beta times of V set only. Why, sir? Why? Actually what will happen? See there, now when your capacitor started charging towards negatively, now the available voltage, see, initially it was 0 voltage. Initially it was 0. That 0 is greater than minus beta we said. That's why output state is changed now. Now your capacitor is keep on charging, negatively charging. Don't forget, see that your capacitor negative plate is connected across the inverting terminal. So this negative voltages keep on rising, negatively increasing. Don't forget, it is negatively increasing. Now what will happen? Exactly after crossing this minus beta times of Vsat. For an example, that minus beta Vsat is equal to minus 5 voltage. For an example, just to take minus beta Vsat is equal to minus 5 voltage. Let us assume like this. இப்போ என்ன ஆகும், இந்த minus 5 voltage நீங்க cross பண்ணி, for example across the inverting terminal when we are crossing this minus 5, for example I am getting minus 5.001 immediately. இந்த வோல்டேஜ் நீங்க கிராஸ் பண்ணும்போது என்ன ஆயிடும் அப்படின்னா, see there this minus beta Vsat is equal to minus 5 voltage according to our assumption, just assumption, assume like this. இங்க minus 5 voltage இருக்கு. When this terminal is crossing this minus 5, now it is become minus 0.0001 only. But you please tell me which value is greater value here. Minus 5 is greater than minus 5.001. We always know in negative minus 5 is greater than minus 5.001. So when your capacitor is crossing minus beta Vsat, that is the triggering point for your non-inverting terminal. Immediately your non-inverting terminal will give the triggering. The triggering is what? Sir, available voltage across the non-inverting terminal will become greater than the value of voltage across the inverting terminal. Sir, why? Because across the inverting terminal now my voltage is crossing minus beta Vsat. If it is go beyond minus beta Vsat, then the voltage across the non-inverting terminal will become greater than, see, across the non-inverting terminal voltage will be fixed. Across the non-inverting terminal voltage will be fixed minus beta Vsat only. Whereas across the inverting terminal your voltages keep on rising because my capacitor can charge up to minus Vsat. It can go up to minus Vsat. But we are not allowing the capacitor can go up to that point, right? Your capacitor won't go up to this point, right? Your capacitor will go up to only minus beta times of Vsat. So that is the point where your state of the circuit is again being changed, right? What will happen? Output is again become plus beta Vsat. Why, sir? A small correction once again. See the conclusion. Capacitor charge ஆகிட்டே இருக்கு, அதோட வேல்யூ வந்து more and more நெகட்டிவா வந்துட்டே இருக்கு. அப்படி நெகட்டிவா வந்துட்டே இருக்கும்போது நான் இன்வெர்ட்டிங் டெர்மினல்ல நெகட்டிவ் வோல்டேஜ் தான் இருக்கு. இப்போ இன்வெர்ட்டிங் டெர்மினல்ல நெகட்டிவ் வோல்டேஜ் தான் வந்துட்டு இருக்குது. இதுல இருக்க நெகட்டிவ் வோல்டேஜ் இங்க இருக்க நெகட்டிவ் வோல்டேஜை விட அதிகமா வரணும். இப்போ இங்க ஃபார் எக்ஸாம்பிள் minus 5 வோல்டேஜ் எடுத்துக்கிட்டேன். இங்க வந்து கரெக்டா minus 5.0001 வோல்டேஜ் வந்தாலும் minus 5 is greater than minus 0.001. So voltage across the non-inverting terminal will become greater than voltage across the inverting terminal. When voltage across the non-inverting terminal will become greater than voltage across the inverting terminal, output state will change as plus Vsat. Once again what will happen? This one will become plus Vsat. Immediately what will happen? Positive voltage will be appeared here. So capacitor இப்ப என்ன voltage இருக்கு? Negative voltage இருக்கா? இப்போ இது positive voltage convert ஆனதுக்கு அப்புறம் direction of the current will change. Then what will happen? There is a diode once again. Now only for a particular time period this capacitor will allow to discharge its energy and then discharge and then it is coming back to zero. அவ்வளவுதான். எனர்ஜி வந்து கெப்பாசிட்டர்ல இருக்க எனர்ஜி வந்து கம்ப்ளீட்டா டிஸ்சார்ஜ் ஆகும். ஃபர்ஸ்ட் இங்க நெகட்டிவ் எனர்ஜி வருது இல்லையா, ஆல்ரெடி கெப்பாசிட்டர்ல சம் நெகட்டிவ் எனர்ஜி இருக்குல்ல, அது கம்ப்ளீட்டா டிஸ்சார்ஜ் ஆகும் when your output voltage will become positive, right? Because already இது சார்ஜ் ஆயிருக்கு, நெகட்டிவ்ல சார்ஜ் ஆயிருக்கு, திரும்ப இது பாசிட்டிவ் சைக்கிளுக்கு போகும்போது சார்ஜ் ஆன வேல்யூ எல்லாம் டிஸ்சார்ஜ் ஆயிட்டு திரும்ப ஜீரோ ஆயிடும். again your diode will turn on. அப்ப diode short circuit direction, again your circuit is coming back to the original state. Okay, so this is the time period of your timer, only one state, அவ்வளவுதான். This is the time period of your timer. Now let us calculate that value. What is the initial value? 0. See there, this is the total time period, right? This is the total time period. Let me consider t equal to t1. This total time period, let me consider t is equal to t1. This is this is the 0 point. We are going to travel up to t1, right? So when t is equal to t1, when t become t1, then available voltage across the capacitor at t equal to t1 will become minus beta times of Vsat. Am I correct? Am I correct? This is the maximum voltage. But the capacitor final voltage is what? Final voltage na meaning enanga? Capacitor can charge up to what? Minus Vsat. Final voltage அப்படினா capacitor maximum எவ்வளவு charge reach பண்ண முடியும்? If I allow the capacitor up to infinity time, அது வரைக்கும் நீங்க allow பண்ணீங்கன்னா capacitor open ஆயிடும். So the voltage across the capacitor automatically will become equal to minus Vsat. Okay, that things at all we know. What is the initial voltage? Initial voltage is 0. Initially there was no energy across the capacitor. Yes, With the help of this collected data, let us try and catch the value of t1, right? I hope you guys are getting me. There was no big operation. If you don't understand, please rewatch the video one more time. You will get the clear idea, right? I don't want to waste the time. Now coming back, we all know the general formula for the capacitor formula Vc of t. Once again, the formula is what? Vc of infinity plus Vc of 0 minus Vc of infinity into e power minus t by tau. Tau is what? Time constant. Tau is equal to RC. R is there is feedback resistance. This one. This is capacitor. I think we are calling it as C1, right? Yes, C1. That is much better, right? Because there was one more spike circuit, right? Fine. Let me substitute all the values. Final voltage is what? Minus V set. Yes. Plus initial voltage is 0 minus final voltage is minus V set into e power minus t by tau. Tau is time constant, we all know, right? Now this is going to be Vc of t, but I don't want this one. At t is equal to t1, I am in need of time period t1. Is that namak theva, right? So at t is equal to t1, Vc of t1 is equal to what? Minus beta V set. When I am replacing this t by t1, this is become Vc of t1, that can be replaced by minus beta V set, which will be equal to, guys listen, at t is equal to t1, the net voltage available across the capacitor will be equal to minus beta times of V set, right? That's all. Don't think too much. Minus V set, minus into minus will become plus V set into e power minus, this t will be replaced by t1. At t is equal to t1 only, we are analyzing this circuit. You please just reduce the circuit. Now what will happen? Let me pass this minus V set to the left hand side such that it is become, now let me remove this circuit because I had given the conclusion. It's over, right? There are no more things to discuss about monostable multivibrator. So that is going to be minus beta times of V set. Just to bring this minus V set to the left side, that is become plus V set, which will be equal to V set into e power minus t1 by tau. Just to take V set outside, it will become 1 minus beta equal to V set cancelled e power minus t1 by tau. Now we know how to cancel this effect exponential because my target is t1, right? Take ln on both sides. So ln of 1 minus beta, which will be equal to what? Minus t1 by tau, right? And it will be equal to what? T1 is equal to minus tau into ln of 1 minus beta. Okay, if you want to pass the minus inside, you can pass. Tau can be replaced by feedback resistance into C1, right? That is here, and into ln of 1 minus beta whole inverse. We can pass this minus inside, so that is going to be RF into C1 into ln of 1 upon 1 minus beta. That is the formula that we are using to calculate the time period of the, what I can say, monostable multivibrator. I hope you guys are getting me, right? So there are no more things to discuss. Okay, yes, so just do remember this formula, that is enough. Okay, fine. Now in monostable multivibrator, this is called what? Quasi state, and this is the maximum time period in which your circuit is acting as a timer. Again it is getting back to a single state, that is called monostate. Okay, a single state will be maintained as what? Stable state, right? So the stable output state அப்படினு output question ல கேட்டாங்கன்னா plus V sat. அதே மாதிரி monostate அப்படினு கேட்டாங்கன்னா என்ன பண்ணுவீங்க? That is a quasi state அப்படினு கேட்டாங்கன்னா minus beta times of V set. Listen guys, sorry, once again. Quasi output state னு கேட்டிருந்தாங்கன்னா minus V set. Monostate, that is a stable state அப்படினு கேட்டாங்கன்னா plus V set, right? For monostable multivibrator. And the time period is, now we know the formula to obtain the time period. That's all. There are no more things to discuss, right? It's over. I hope you guys are getting me, right? See, with this, my part is completed, right? Analog electronics whole syllabus is completed, right? And there was a small part, that is operation amplifier characteristics. Sir told he is uploading that lecture because he is taking that one, right? He requested me, no problem, I will take, he will handle that things, right? So that video will be uploaded, right, in our link. And there was a small topic in our measurements, that is called transducer, right? So let me complete that transducer also, right? Because later only I have seen that one. Keep that thing. Now we are going to discuss about transducer, right? See the characteristics of op-amps, sir will handle, right? Who is taking analog electronics? That is very small topic. I think today itself he will upload. Fine. Next we are going to discuss about a transducer. Sir, what is the purpose of this transducer? Actually, what we are doing in transducer, right? That's very simple. There are no big things to discuss. Let me complete, right? Quickly. Transducer. Transducer அப்படின்னா நம்ம எல்லாருமே படிச்சிருப்போம், ரைட்? இதோட பர்பஸ் என்ன அப்படின்னா, it will convert the energy from non-electrical form to electrical form. If I have some non-electrical energy, you may have some non-electrical energy, right? The best examples for non-electrical energies are pressures, right? The most often converted quantities are pressure, illumination of light, illumination of light, and temperature, right? The available forms are illumination of light, temperature, and pressure. Now these non-electrical quantities, right, are being transformed with the help of some type of devices, are called transducers, and it will be converted into the form of what? Electrical energy. It will be converted into the form of electrical energy, right? That's all. I hope simply you guys are getting me, right? So non-electrical energy will be, that is non-electrical quantities will be converted as what? Electrical quantities with the help of a device. The device is simply called a transducer. Okay, now there are two type of transducers are there. One is called active transducer and another one is called passive transducer, right? So there are two type of transducers are there. That is in this transducer, active transducer, passive transducer. Let me define. Under active, we have three main, that is major classification. One is called piezoelectric transducer, one is called piezoelectric transducer, right? And second one is called photoelectric transducer, right? And there is one more type of transducer there, that is called thermoelectric transducer, right? Thermoelectric transducer, right? So these three guys are lies under active classification, whereas under passive we have three types. Once again, resistive type of transducer, that is resistor transducer, and the second one is inductor transducer. They are called passive. We all know RLC is always called what? Passive elements, right? So resistor transducer, inductor transducer, capacitor transducer, right? So there are three more classification under passive type of transducer also, right? Now various, in case of active transducer, external supply does not require, that is called self energy generator. This is called what? Self energy generator, right? So this is called regenerative energy generator. We can also call it as regenerative energy generator, right? So in active we have what? There is no need of external supply. No external supply should be required here. Whereas for your passive transducer, external supply should be required. Guys, listen, whichever the things that I am giving here, that I am giving these things in an exam point of view, because I know in which area they can take the question from here, right? So in active transducer, we are not producing any external supply. It is a self energy generator. Whereas in case of passive, resistor, inductor, capacitors are not having the capacity to generate the energy, right? So that's why they are called passive elements, right? Why we are calling it as active element? Active element means he's a person who is handling, that is a person who's having the ability to generate the energy by self, right? That is called what? Active supply, right? That is active sources, right? Yes. Whereas passive elements means it won't having the ability to generate the energy, right? So external supply should be required to handle these persons, right? Whereas the best example for inductor is LVDT, linear variable differential transformer, right? Linear variable differential transformer, right? So that is the best example where we are using the inductor. Actually what we are doing, sir, with the help of this active transducer, we are converting the energy from one form to another form. Actually I told you, in transducer what we are going to do, we are simply trying to convert the energy from non-electrical form to electrical form. Yes sir. Under this process, right, active transducers are taking the heart, right? They are going to be the heart of this active transducer, because active transducers only will going to take this action. Active transducers are going to convert the energy from non-electrical to electrical form. Then what is the purpose of this passive transducer? Actually, this action will going to be done by active transducer. Then what is the purpose of this passive transducer? I am repeating once again. We are going to convert the energy from non-electrical to electrical with the help of active transducer, with the help of piezo, photo, thermo. See there, piezo for pressure, photo for elimination of light, temperature, that is thermo for temperature. Is it over? Yes. So active transducers are going to play with the physical quantities and they are going to convert the energy from non-electrical to electrical quantity. Then what is the purpose of this passive, sir? They are acting as a, right? If you want to obtain variable resistance in the output zone, if you want to obtain variable inductance, if you want to obtain variable capacitance, right? So variation in the capacitor, variations in the resistor, variations in the inductor could be possible. If you want to obtain variable values, right? So inductance la or variation venum, illa capacitance la variation venum, illa resistance la variation venum appadina, then you can give priority for positive, right? That is passive elements. Okay, with the help of external supply we are going to vary, right? We are going to produce the variance, right? We are going to vary the value of resistor, inductor, capacitor. I hope things are good. You guys are understanding what I'm trying to conclude. Clear? So that is the difference between active transducer and passive transducer, right? So let us slightly discuss about this what I can say, piezo, photo, thermo, resistor, inductor, capacitor. Guys, I'm not going in depth because I'm just touching your syllabus, right? Because I cannot go IES syllabus at all. That syllabus is a little bit vast, right? Fine. So let us discuss about this piezo, what I can say, photo and thermo slightly, right? So what do you mean by piezoelectric transducer? Piezoelectric transducer அப்படினா என்ன? What is the purpose of that piezoelectric transducer, right? So piezoelectric transducerல நம்ம என்ன பண்ணோம் அப்படினா, we are taking pressure as the input quantity and we are going to convert this pressure into electrical energy, right? Pressure வந்து இதுக்கு இன்புட்டா வந்து நம்ம பாஸ் பண்ணுவோம் piezoelectricல, right? So in piezoelectric we are using various type of materials. Let me define all those things. So first let us discuss about piezo. Okay, actually in piezoelectrics we are using Rockley's salt, the materials, right? Rockley's salt to produce the mechanical strength, to increase the mechanical strength we are using Rockley's salt. We can also use tourmaline, quartz, right? They are majorly used materials. Quartz, tourmaline, right? And apart from that we are also using lithium sulfate, sorry guys, lithium sulfate, barium titanate. Another one is what? Barium titanate. These are the materials that we are using in case of piezoelectric, right? Simply what we are doing, pressure will be transformed as electrical energy. Electrical energy na enanga, it will be converted into the form of current and voltages. That's all, right? With the help of what I can say, piezoelectric transducer. Just to remember, that is enough, right? Fine, sir. Next, idhula adhigama use pandra moonu material yarunu pathina, these three, right? Okay, இவங்க மூணு பேர் தான் நீங்கள் வந்து அதிகமாக யூஸ் பண்ணுவீங்க, right? Now here let me arrange the order. First we are considering Rockley salt, and then we are using quartz, and then we are using tourmaline, right? So I am writing it in ascending order. That is based on the mechanical strength, right? If you want more mechanical strength, then you are supposed to use tourmaline. Moderate, you are supposed to use quartrate, that is quartz. If you want low mechanical strength, we are giving priority for Rockley salt, right? So this is the way that we are using, what I can say, different type of materials to convert the energy from pressure to what? Electrical quantity. Electrical quantity means what? Current and voltage. It will be converted in the form of current and voltages, right? One second. Sorry guys. Okay, fine. So this is all about piezoelectric, right? And see, actually what I had been concluded, the major purpose is we are using, that is pressure, right? We We are trying to convert the pressure into the form of what? Current and voltage quantity, right? And we can also do some other things here. We can also do some other things in the sense, we can also, that is the quantities that we can measure with the help of piezoelectric crystal, right? இதை யூஸ் பண்ணி நம்மளால என்னென்ன things எல்லாம் மெஷர் பண்ண முடியும் சார், right? With the help of this piezoelectric crystal, we can measure pressure. First thing, we can measure pressure, right? And apart from that, we can also measure temperature. We can also measure wait a minute. Sorry guys, we can also measure a temperature. Okay, and we can also measure acceleration. We can also measure acceleration. And one thing, in the pressure learn that sometimes in examination they will give you static pressure or dynamic pressure. Remember one thing, both static and dynamic pressures can be measured with the help of piezoelectric. Okay, I hope you guys are getting right. Yes. Okay. Next, in piezoelectric, what is the sensitivity of piezoelectric, right? You will be requested to find out the sensitivity, right? Sensitivity of piezoelectric. Guys, I'm just touching your transducer, that's all. I'm repeating once again, right? Sensitivity, that is what it is actually defined as developed voltage, field developed voltage, right, per unit stress. Per unit stress, by using the pressure only we are measuring this sensitivity of the device, that's all. Amount of voltage that will be developed, right, with the help of what amount, that is pressure, that is input side we are giving stress, right? So based on the unit stress you will be defined as, that is you can define the sensitivity. If stress is more, then sensitivity will be less. If stress is less, then sensitivity will be more. Clear? That's all. This is all about piezoelectric. And second thing we saw, that is photoelectric, right? Photoelectric transducer, that is very simple. In photoelectric transducer there was no big things to understand, right? What we are trying to do in photoelectric transducer, that is very simple. The process is actually, whenever we are passing the lights from the outside, there was two plates, right? We are simply calling it as diode principle. It will works under the principle of diode only, right? In the its layout is diode only, right? So this terminal we are calling it as cathode, this is going to be anode, right? So let me connect it with a battery here. Let us connect it with the battery, right? Some internal resistance also we can consider here, right? Actually what will happen, whenever light is incident, right? So light is getting hit your cathode plate. Cathode plate எப்பப்பெல்லாம் வந்து லைட் வந்து ஹிட் பண்ணுதோ அப்பெல்லாம் என்ன ஆகும் அப்படின்னா, that's the hitting lights, that is incident, that is called photo emission, right? So whenever this photo is getting, right, this going to be incident your cathode, automatically what will happen, this cathode will started releasing the electrons. The cathode will started releasing the electrons, right? So that releasing electrons is getting attracted by the anode. Why? Because anode is that is made by what? Positive charges, right? Cathode is made by negative charges, right? So whenever your photo is, that is your electrons or your lights is going to be incident your cathode, cathode will release electrons. That electrons are getting attracted by this supply. It means electron will started traveling in this direction. See that is the direction of your electron. Then what is the direction of current? Current will go from what? Anode to cathode. So this is the direction of current. So current is started coming like this. That's all. It's over, right? So what is the simple operation here? That is called the photo illumination effect, right? So it's working under the principle of light intensity, right? So that is photo light intensity, right? Light on the evlo intensity on the level, what will happen? Based on that intensity, it is proportional to what? Production of electrons, right? So it will produce intensity அதிகமாயிட்டே போனது அப்படினா, it will produce more electrons from the cathode. It will automatically more amount of current is started flowing through the circuit. You can measure it in the output side, right? அப்ப இங்க current வந்து எவ்வளவுக்கு எவ்வளவு flow ஆகுது, current இங்க அதிகமாயிட்டே போகுது அப்படினா, it means we are passing more amount of what I can say lights. So very simple now, light energy will be converted in the form of what? Electrical energy. That's all. There are no more things to discuss here, right? Just you will be tested. இங்க question என்ன கேட்கலாம் அப்படினா, எந்த principle யூஸ் பண்ணி வந்து இத நம்ம பண்றோம் அப்படினு கேட்கலாம். That is photoelectric intensity principle. That is right. light intensity அதிகமாக automatically what will happen, it will produce more electrons. That electrons is getting attracted by positive plate, so electrons போற travel direction க்கு opposite ல current flow இருக்கும். Just we can measure that current in the output side ஒரு ammeter போட்டு. அப்ப நீங்க என்ன பண்ணிக்கலாம், current எவ்வளவுக்கு எவ்வளவு அதிகமாகும், light intensity அதிகமானா current அதிகமாகும், light intensity கம்மியா இருந்தா current கம்மியா இருக்கும். So ammeterல நீங்க measurement வச்சு readings வச்சு சிம்பிளா சொல்லிடலாம், right? Yes, எவ்வளவு emission வந்து நடந்துட்டு இருக்கு அப்படிங்கிறது, right? So that is the conclusion. Sorry guys. Okay, next let us discuss about last type. See, we are in active transistor, right? So the last one is thermo, right? Under thermo there are two classification. One is called thermistor, and another one is called thermocouple transducer. One is called thermistor, another one is called thermocouple transducer. Okay, the often used transducer. See, thermistor is fast, right? It is work at a very speed, right? So it is fast and stable, we can call. When I am comparing thermocouple, thermistor is fast and stable, but the often used device is thermo, that is conveniency. ஆனா practically வந்து எந்த device வந்து ரொம்ப comfortable நமக்கு இருக்கும் அப்படினு பாத்தீங்கன்னா thermocouple, right? So it is often used device. Practically the often used device is thermocouple, though it is very fast and stable. But designing this circuit, when I am comparing, here we have more losses and manufacturing cost and investigation, that is இத compare பண்ணி பாக்கும்போது, right, during that investigation thermocouple will become what, that is more convenient for the practical application. So priority will be always given for thermocouple type of instruments, right? So which is the most that is often used device here, that is called what, thermocouple, right? But which is more sensitive, the more fast, stable and more sensitive device is thermistor, right? Sometimes it is also got a more sensitive device, right? See, first of all, what do you mean by thermistor? Thermistor அப்படினா it is nothing but resistor, அவ்வளவுதான். That resistance is depends on the temperature, அவ்வளவுதான். So அப்ப temperature எவ்வளவுக்கு வேரி ஆகுதோ அவ்வளவுக்கு என்ன ஆகும், resistance is keep on vary. So based on the temperature, அப்ப temperature வந்து increase பண்ணிட்டே இருந்தீங்க அப்படினா, for example I have ஒரு temperature நீங்க electrical energy convert பண்ணனும். Now what will happen here, actually this thermistor will work on the principle of, that is based on the principle of negative temperature coefficient. First of all, it will works under the principle of negative temperature coefficient. It means whenever your temperature is keep on raising, input side la வந்து for example I am having some temperature, the temperature is keep on raising here. If your temperature is keep on raising, automatically in the electrical circuit the value of the resistance is keep on getting decreased, the variable resistance is keep on getting decreased. That is called a negative temperature coefficient. Negative temperature coefficient means resistance and temperature are reciprocal to each other, that is called a negative temperature coefficient. Whereas positive temperature coefficient means temperature is directly proportional to resistance. So this is for negative temperature coefficient, negative temperature coefficient NTC. This is called positive temperature coefficient PTC, right? Whereas here in case of thermistor we are using, it works under the principle of NTC, negative temperature coefficient, right? So whenever there is an increment in the temperature, automatically resistance will decrease, that decrement in the resistance will increase the current. Now we can easily measure the electrical quantity in the output side. Clear? So this is all about thermistor, very simple, right? Yes. Now what is the conclusion? So current flow is depending on what, this resistance and as well as temperature also, right? I hope you guys are getting me, right? Fine. Okay, next what we have to understand, we need to discuss about thermocouple, right? So let me discuss about thermocouple also. That is very simple. In thermocouple we are having two different materials, right? And they are going to be joined together, right? And see, one thing is, this is material 1, this is material 2, this is the point there we are going to, where we are going to join these two junctions, right? It works under the principle of, once again, right, once again we are going to transform the energy from thermal form, that is temperature, to what, voltage, right? So here the variations in these two junctions, let me measure, that is the temperature T1. The thing is, you can simply understand, when these two metals are having two different temperature, automatically the temperature difference will produce the energy. When this, or we can also consider T2 minus T1 or T1 minus T2, that will be directly proportional to the EMF development, right? When there are two metals are there, when there is a difference between these two metals temperatures, right? So let me define temperature offered by the metal one is T1, this is T2. இவங்க ரெண்டு பேருக்கு நடுவுல கிரியேட் ஆகிற டெம்பரேச்சர்ல டிஃபரன்ஸ் வந்துச்சு அப்படின்னா ஆட்டோமேட்டிக்கலி EMF will be generated. That's all. When the difference is more, EMF generation will be more. We can simply measure this electrical quantity in the output side. Clear? So that is the basic principle behind of thermocouple, right? So when I am comparing the thermistor, thermocouple is often being used in the practical circuits, right? Sorry guys. Okay, fine. So here let me write it here. Actually, once upon a time I was being appeared for an interview of instrumentation department, right? Unknowingly it was happened when அவங்க என்ன பண்ணிருந்தாங்க அப்படின்னா they asked me a very simple question. That simple question is simply I have a thermistor, right? ஒரு thermistor வந்து அவங்க என்கிட்ட கொடுத்துட்டு okay, thermocouple is there and thermistor also will be there, right? We are calling it as thermistor வந்து more sensitive device and it is more fast and more stable அப்படிங்கிறது எல்லாமே ஓகே தான். And but thermocouple வந்து is often, right? People are calling it as this is the device and it will be often being used in the practical circuits. Okay sir, that is correct, right? நம்ம இதை வந்து ரொம்ப கன்வீனியன்ட்டாக இருக்குது அப்படின்ட்டு நீங்கள் டிஃபைன் பண்ணுறீங்க இல்லையா? ப்ராக்டிக்கல் சர்க்யூட்ஸில் இதுதான் வந்து மோர் கன்வீனியன்ட் அப்படின்னு நீங்கள் டிஃபைன் பண்ணியிருந்தீங்க, ரைட்? அப்பார்ட் ஃப்ரம் தட் இஸ் தேர் எனி அதர் தியரிட்டிக்கல் ரீசன்ஸ் ஆர் தேர்? இப்போ நீங்கள் ப்ராக்டிக்கலாக ஓகே யூ ஆர் டெல்லிங் திஸ் திங்ஸ், ஓகே ஐ அண்டர்ஸ்டுட் ஆல் தீஸ் திங்ஸ், ரைட்? கேன் யூ சே இஸ் தேர் எனி அதர் ரீசன்ஸ், வேலிட் ரீசன் ஃபார் திஸ் சர்க்யூட், ரைட்? வேலிடாக வேறு ஏதாச்சும் ரீசன்ஸ் இருக்கா இந்த சர்க்யூட்டுக்கு வந்து நம்ம ப்ரையாரிட்டி கொடுக்கறதுக்கு, லைக் ஃபார் தெர்மோகப்பிள் அப்படின்னு கேட்டாங்க, ரைட்? தி திங் இஸ் ஆக்சுவலி in the practical industry சைடில் என்ன பண்ணிட்டு இருப்பாங்க அப்படின்னு பார்த்தீங்கன்னா தெர்மிஸ்டரில் வந்து there is a big problem. That problem is variable resistor. Everyone can understand here. இது இந்த சர்க்யூட் நம்ம பார்க்கும்போது என்ன ஆகும் அப்படின்னா the property of the resistor is keep on varying with respect to the temperature. The conclusion is if the temperature is okay, resistance is vary, that things are all okay sir. ஒரு ரெசிஸ்டன்ஸோட பிஹேவியர் வந்து வித் ரெஸ்பெக்ட் டு டெம்பரேச்சர் வந்து வேரி ஆகிட்டே இருக்குது அப்படின்னா இட் இஸ் ஆல்சோ சேஞ்சிங் இட்ஸ் பிஹேவியர் வித் ரெஸ்பெக்ட் டு டைம் ஆல்சோ. Do you guys agree with me? Because whenever a quantity is changing its property with respect to someone, at the same time it will also change with respect to time. இப்போ நான் ஸ்டார்டிங்கில் at 10 degree Celsius my value is 10 ohm and then 20 degree Celsiusல வந்து my value வந்து 15 ohm வருது அப்படின்னா 10 degree Celsiusலேருந்து 20 degree Celsiusக்கு போகும்போது there was some changes in the time also, not? There was some changes in the time also, right? Yes or no? Yes sir, yes, definitely. So the conclusion is when a person is keep on changing its property with respect to time period without having any linearity, then that person behavior is called what? Non-linear behavior, right? So there is one more drawback, right? See, actually when they were tested me in that industry, later on I understood this statement is correct, right? The thing is sir, resistance is non-linear behavior because it was keep on changing with respect to time period. So resistance behavior in case of thermistor, there is a big problem in this. What I can say, theoretically we can prove it, but in the practical laboratory they were done some changes and adukapra avanga use pannittu irundanga and then I have visited the laboratory, I understood that things, right? Because they only explained these things for me, right? The thing is though this resistance வந்து வேரியபிளாக இருக்கு and it is producing what? Non-linear behavior. ஒரு non-linear behavior வந்து இது ப்ரொடியூஸ் பண்ணிட்டு இருக்கிறதால, right? That is also one more reason why we are giving priority for thermocouple, right? Non-linear behavior in the sense non-linear characteristics of any persons cannot be guessed. எஸ் ஆர் நோ? ஒரு பர்சன் வந்து டைம் வந்து அவரோட பிஹேவியர் வந்து எப்பயுமே சேஞ்ச் பண்ணிட்டே இருந்தார் அப்படின்னா அதை நம்ம கெஸ் பண்ண முடியாது, ரைட்? ஸோ தட் இஸ் கால்டு வாட்? நான் லீனியர் பிஹேவியர், ரைட்? ஸோ தி திங் இஸ் வாட்? தட் இஸ் ஆல்சோ ஒன் மோர் ரீசன் வை வி ஆர் நாட் யூசிங் வாட்? தெர்மிஸ்டர், ரைட்? நவ் தி அனதர் கொஸ்டின் இஸ் கமிங் பிளேஸ். ஓகே சார், இப்போ நம்ம லெபார்ட்டரியில் தெர்மிஸ்டர் தான் இருக்கு, நான் தெர்மிஸ்டரை தான் வச்சு வந்து எனர்ஜி வந்து கன்வெர்ட் பண்ணணும் டெம்பரேச்சர் அப்படின்னா வாட் வில் டூ? இஸ் தேர் எனி அதர் further choices will be there? Yes, they have done one more thing. Across the variable resistor they had connected a fixed resistance, right? Such that the variations and the non-linear behavior ஓட எஃபெக்ட் வந்து தியரிட்டிக்கலா வந்து வெளியில தெரியல. ப்ரூவ் பண்ணி பார்க்க டெரிவேஷன்ஸ் வந்து நம்ம போட்டு பார்த்தோம் அப்படின்னா this resistance is fixed resistance. By connecting a fixed resistor across the variable resistance, the changes in the அப்ப நீங்க சர்க்யூட் இப்போ parallel resistance வந்து நம்ம ஈக்குவலன்ட் வேல்யூ போடும்போது என்ன ஆகும் அப்படின்னா ஒரு one வேல்யூல இருந்து நீங்க another வேல்யூக்கு போகும்போது there was no big changes in the value of the resistance, right? So such that non-linear behavior can be improved, right? Listen guys, it cannot be eliminated. ஒரு ஃபிக்ஸ்ட் ரெசிஸ்டர் போட்டால் எலிமினேட் ஆகிடுமா? நோ சார், நாட் லைக் தட். நமக்கு தேவை ரெசிஸ்டன்ஸில் வேரியேஷன் வரக்கூடாது. ஸோ ஜஸ்ட் பை கனெக்டிங் அந்த ரெசிஸ்டரை கனெக்ட் பண்ணுறதால என்ன ஆகும் அப்படின்னா வேரியேஷன்ஸ் கேன் பி reduced, it cannot be eliminated, right? So that is how we are modify பண்ணி அவங்க laboratory யூஸ் பண்ணிட்டு இருந்தாங்க. But why we are giving often, that is priority for this one, that is first one is conveniency, second one is thermistor, it's keep on changing its property with respect to temperature, right? Because of that its behavior is non-linear, that non-linear behaviority, because of that one also we are giving, that is one more reason why we are giving priority for thermocouple. Anyway, if you want to use thermistor தான் நீங்க யூஸ் பண்ண அப்படின்னா we can do by minimizing the effect of this non-linear behavior by connecting a what, right? By connecting a resistor in across with the variable resistor. Fixed resistor will be connected in across with the variable resistor. Clear? So this is all about thermistor and thermocouple circuits, right? One second. Okay. And one more thing is, sir, இப்போ நீங்க பாத்தீங்கன்னா இது ரெண்டுத்தையும் கம்பேர் பண்ணி பாத்தீங்க அப்படின்னா in a temperature device, that is in thermistor I am talking about current, in thermocouple I am talking about voltage. நீங்கள் இது சிம்பிளாக அப்சர்வ் பண்ணி பார்த்தீங்கனாலே தெரியும், டெம்பரேச்சரில் வேரியேஷன்ஸ் வரும்போது வோல்டேஜ் வந்து டெவலப் ஆகுது இன் கேஸ் ஆஃப் தெர்மோகப்பிள் சர்க்யூட். அப்போ டெம்பரேச்சர் வந்து நம்ம வந்து என்ன பண்ண முடியாதுன்னா ட்ரிமாண்டஸ் அமௌண்ட் ஆஃப் டெம்பரேச்சர்ஸ்லாம் வந்து இங்கே என்ன பண்ண முடியாதுன்னா உங்களால் அப்ளை பண்ண முடியாது. அவ்வளோ பெரிய மெட்டீரியல்ஸ் எடுத்துகிட்டு போய்ட்டு நீங்கள் டெம்பரேச்சர் வந்து டிஃப்ரென்ஸ் ப்ரொடியூஸ் பண்ணி வோல்டேஜ் வந்து நீங்கள் மெஷர் பண்ணுறது ஜென்ரேட் பண்ணுறதுலாம் வந்து பாசிபிளான விஷயம் கிடையாது. வி கேன் கோ அப் டு சம் ரெஸ்ட்ரிக்டட் ரேஞ்ச் ஒன்லி, ரைட்? ஸோ வாட் இஸ் தி level of voltage that we can receive in case of thermocouple circuit, right? So it is best suitable device for low voltage circuit. This thermocouple is best suitable for low level voltages only. High voltage level ku neenga poga mudiyadhu, because high voltage appadinala automatically temperature difference has to be very high. Avlo periya idukla nama idha use panna mudiyadhu, that is not possible. So it will be suitable for what? Low level voltages, right? It will be suitable for low level voltages. That is called your, that is thermocouple circuits, right? I hope you guys are getting me, right? Okay, now we need to discuss about some other people, that is I told you passive elements, right? But passive elements la nama enna padum, that is very simple. Let me teach you how to vary the value of resistance and how to vary the value of inductance and how to vary the value of capacitor. That is called passive transducers, right? So for resistor we can simply say R is equal to rho L by A. So by changing resistivity we can change the value of resistance in the output side. By changing length of the wire, that is resistive wire rheostat, we can increase the value of resistance, right? You can change, that's all, increment or decrement. And by increasing the area of the wire also we can change the value of resistance. That is how we are producing variable resistance. So variable resistance practically could be possible by changing resistivity, that is property of the material, length of the material, area of the material. Whereas inductance L, right? How will you calculate the value of L? If you want to produce the inductance, let me write the simple formula. Inductance L is equal to N square by S, where S denotes reluctance of the material. S denotes the reluctance offered by the material. We all know reluctance S is equal to what? L divided by mu times of A. See guys, already we had been concluded all these things in electrical machines, right? And the network analysis also in magnetic coupling circuits. I hope I had been discussed about these things, right? You can just revise all those things, right? Now, okay, let us coming back. Substitute this reluctance formula here such that inductance will become L become N square upon L by mu times of A. So if I will reduce this further, it will become mu A N square by inductance L. So there are four parameters, right? By changing the permeability of the material we can change the inductance, or by changing the area we can measure the inductance, or by changing the number of turns we can measure the inductance, or by changing the, see there, this is number of turns, this is length of the wire. Both are not same, right? Yes. So by changing number of turns we can change the inductance. By changing the length of the material we can change the inductance. That is how we are producing variable inductance in case of what I can say passive transducer, inductive transducer, right? So in case of capacitor, very simple. C is equal to what? Epsilon naught A by D, where A once again denotes, A stands area of the plates, right? The area between the capacitor plates, and D denotes the what? A distance between the positive plate and a negative plate, right? Area stands, right? D denotes the distance between the positive plate and a negative plate, and epsilon naught we know that is called permittivity of the material, right? Yes, when permittivity will be more, automatically capacitance will be more. when permittivity will be less, automatically capacitance will be reduced, right? Anyway, what is the conclusion here? Capacitance, variable capacitor could be possible by changing the what permittivity of the material, area of the that is plates, or distance between the plates, right? So there are three people are there to change the value of capacitance offered by the material, right? I told you this is the measure. This person is simply called what? It is used to measure. It is used in what? Linear variable differential transformer, right? And it is working under the principle of mutual inductance. We know what is the basic principle of transformer, that is mutual inductance between the primary and the secondary circuits, right? It's working under the principle of mutual inductance. One second. Yeah, that's all, right? I hope you guys are getting me what I'm trying to conclude. It's over, right? Okay, fine, sir. Next, what we are going to discuss, the another type, this is all about transducer. It is over. Basic classification is completely over. Next, we need to discuss about few more things, that is simply called see, let me remove this one. Let us discuss about a data acquisition system, right? Data acquisition systems, a very simple circuit, that is very small topic. First we have to understand, that is what is the purpose of this data acquisition system, and where we are going to use this data acquisition system. One second, guys. Please, few seconds, because I'm not okay. So let us discuss about data acquisition system. The data acquisition system அப்படிங்கிறது என்ன அப்படின்னா, it is very simple. இதில் வந்து ஒரு சில எலக்ட்ரானிக் டிவைசஸ் எல்லாம் வந்து நம்ம என்ன பண்ணுவோம் அப்படின்னா ஒன்றா கம்பைன் பண்ண போகிறோம், இன்க்ளூடிங் அவர் டிரான்ஸ்டியூசர், ரைட்? நம்ம எல்லாத்தையுமே வந்து ஒன்றா கனெக்ட் பண்ணிவிட்டு வாட் we are going to do, right? So there are two type of process that we are going to do, right? So in the data acquisition there are two type of devices are there. One is analog type data acquisition system, and another one is digital type of data acquisition systems are there, right? Okay, sir, what is the purpose of this data acquisition systems, and where we are going to use these data acquisition systems? Very simple, right? இப்போ நம்ம என்ன சொல்லலாம் அப்படின்னா, இப்போ இந்த அனலாக் டு டிஜிட்டல் கன்வெர்ட்டர் பற்றி நம்ம டிஸ்கஸ் பண்ணியிருக்கோம், டிஜிட்டல் டு அனலாக் கன்வெர்ட்டர் பற்றி நம்ம டிஸ்கஸ் பண்ணியிருப்போம், அப்புறம் ஃபிளிப்லாப் சர்க்கியூட்ஸ், மல்டிப்ளெக்சர், டிமல்டிப்ளெக்சர்ஸ், ரைட்? ஆல்ரெடி இவங்க எல்லாரோட ஆப்ரேஷன்ஸை நம்ம ஏற்கனவே பார்த்துருக்கோம், கரெக்டாக? இப்போ இந்த எல்லா ஆப்ரேஷனையும் வந்து ஒன்றா கம்பைன் பண்ணி ஒரு ஸ்பெசிஃபிக்கான ஆப்ரேஷன் வந்து நீங்கள் ப்ரொடியூஸ் பண்ணுறீங்க அப்படின்னா, தட் இஸ் கால்டு டேட்டா அக்யூசிஷன். ஆக்சுவலாக இது நம்ம என்ன சொல்லலாம் அப்படின்னா, வி கேன் பர்ஃபார்ம் அரித்மெட்டிக் ஆப்ரேஷன் பர்ஃபார்ம் பண்ணுறது, மல்டிப்ளிகேஷன், டிஃப்ரென்ஸ், ஒரு டேட்டா வந்து நீங்கள் டிஜிட்டல் டிஸ்பிளே பண்ணுறது, இல்லை ஒரு அனலாக் குவான்டிட்டியை வந்து நம்ம வெளியில் ஃபிசிக்கலாக நம்ம ஒரு வாட்சில் வந்து சிம்பிளாக சொல்லணும் அப்படின்னா, a set of electronic devices, right? Combinedly they are going to perform a specific task, that is simply called a data acquisition system. Analog type of system will be there, digital type of system will be there. இப்போ நம்ம வீட்டில் இருக்க அனலாக் வாட்ச், right? That is called analog type of system, right? இது digital display அப்படின்னா நம்மளோட மொபைல், that is called digital data acquisition system. அப்போ அதில் என்ன ப்ராசஸ் நடக்கும்? வெரி சிம்பிள். இன் கேஸ் ஆஃப் டிஜிட்டல் டேட்டா அக்விசிஷன் சிஸ்டம், ஃபர்ஸ்ட் யுவர் எனர்ஜி வில் பி கன்வெர்டட் ஃப்ரம் வாட் நான் எலக்ட்ரிக்கல் குவான்டிட்டி எலக்ட்ரிக்கல் வந்து நீங்கள் கன்வெர்ட் பண்ணுறீங்க, ஒரு எனர்ஜி வந்து அவைலபிள் எனர்ஜியை. அண்ட் தென் எலக்ட்ரிக்கலில் அனலாக் சிஸ்டமாக இருந்தது அப்படின்னா, அனலாக் வாட்சில் வி ஆர் கோயிங் டு சிம்பிளி வாட் நமக்கு என்ன எனர்ஜி தேவையோ அதுக்கான கன்வெர்ட்டரை யூஸ் பண்ணி, ஃபார் எக்ஸாம்பிள் சார் எங்கிட்ட டிஜிட்டல் சிக்னல் இருக்குது அப்படின்னா, ஆனால் எனக்கு அனலாக் சிக்னல் வேணும் அப்படின்னா டிஜிட்டல் டு அனலாக் கன்வெர்ட்டர் போட்டுட்டு அதுக்கப்புறம் என்ன பண்ணும், இட்ஸ் கரஸ்பாண்டன்ட் டிஸ்பிளே, ரைட்? லைக் அவர் வாட்ச், ஐ எம் யூசிங் அனலாக் வாட்ச், ரைட்? ஸோ டேட்டா வில் பி டிஸ்பிளேட் இன் தி ஸ்க்ரீன், ரைட்? ஸோ தேர் யுவர் கவுண்டர் இஸ் இட் இஸ் கீப் ஆன் ரொட்டேட்டிங், பட் அனலாக் ஐ எம் கெட்டிங் தி டைம் இன் டர்ம்ஸ் ஆஃப் வாட் அனலாக் சிக்னல், ரைட்? ஸோ இதே மாதிரி ஒரு டிஜிட்டல் டேட்டா அக்விசிஷன் சிஸ்டம் அப்படின்னா we are trying to measure the energy in terms of digital quantities, like நீங்கள் டிஜிட்டல் வாட்ச் will be there, digital mobile will be there, our television, அதுக்குள்ளே நடக்கிற எல்லா ப்ராசஸுமே வந்து நம்ம என்ன சொல்லுவோம் அப்படின்னா, simply we are calling it as digital data acquisition systems, right? Yes, I hope you guys are getting me. Anyway, let me simply say, in case of இப்போ அதில் மேஜராக வந்து யார் யார் இருப்பாங்க அப்படின்னு பார்த்தீங்கன்னா, டிஜிட்டல் டேட்டா அக்விசிஷன் சிஸ்டமில் ஃபர்ஸ்ட் we are having transducer, and then we have signal conditioner, and then we have signal conditioner, and then we have recording instrument, and then we have recorder. That is the basic circuit of data acquisition system. Okay, ஸோ இப்போ இங்கே என்ன நடக்கும் அப்படின்னா, வித் தி ஹெல்ப் ஆஃப் டிரான்ஸ்டியூசர் வி கேன் கன்வெர்ட் எந்த ஒரு எனர்ஜி நீங்கள் எலக்ட்ரிக்கல் எனர்ஜியாக கன்வெர்ட் பண்ணிக்கலாம், ரைட்? அண்ட் தென் வி ஆர் யூசிங் சிக்னல் கண்டிஷனர் அண்ட் ரெக்கார்டர் டிவைசஸ். சி ஐ சிம்பிளி டோல்டு டேட்டா அக்விசிஷன் சிஸ்டமில் தெர் ஆர் டூ டைப்ஸ் இஸ் சார். ஒன் இஸ் அனலாக், அனதர் ஒன் இஸ் டிஜிட்டல், அவ்வளோதான். இதில் சிம்பிளாக நீங்கள் திங்க் பண்ணி பார்க்குறதுக்கு எதுவுமே கிடையாது. அனலாக் அப்படின்னா அனலாக் குவான்டிட்டிஸ் இப்போ நம்ம வாட்சில் பார்க்குறோம். இந்த மாதிரி வாட்ச் மட்டும் கிடையாது, என்னென்ன அப்ளிகேஷன்ஸ்லாம் வந்து அனலாக்ல நீங்கள் பார்க்குறீங்க, ரைட்? டிஜிட்டல் போர்டு இல்லாமல் பார்க்குறது, அது எல்லாமே வந்து அனலாக் டேட்டா அக்விசிஷன் சிஸ்டம்ஸ் தான். டிஜிட்டல் டேட்டா அக்விசிஷன் சிஸ்டம்ஸ் அப்படின்னா எந்தெந்த குவான்டிட்டிஸ்லாம் வந்து நம்ம டிஜிட்டலில் பார்க்குறோம், அதான் நான் எக்ஸாம்பிள் சொன்னேன். நம்ம டெலிவிஷன் சொல்கிறது, கம்யூனிகேஷன் சேனல்ஸில் நம்ம யூஸ் பண்ணலாம். டேட்டா வந்து எங்கெங்கெல்லாம் டிஜிட்டலில் ட்ரான்ஸ்மிட் பண்ணுறீங்களோ, டிஜிட்டலில் டிஸ்பிளே பண்ணுறீங்களோ, அண்டர் தட் கிளாஸஸ் தட் இஸ் we are giving priority for what I can say digital data acquisition systems, right? So there are no more things to discuss about these two persons, that's all, right? So this is all about data. That is a small topic, that is also it was given in your TRB syllabus. I think I have seen it, right? You can just make a note of it, that is enough, right? That's all. With this measurement is completely over. So finally we had been discussed about transducer. There are two type, active and passive. Transducer க்கு அப்புறம் ஒரு ஸ்மால் பார்ட் தான் டேட்டா அக்விசிஷன் சிஸ்டம். இட் இஸ் தி பார்ட் ஆஃப் என்டையர் சிஸ்டம். ஸோ எல்லா எலக்ட்ரிக்கல் இது வரைக்கும் நம்ம பார்த்ததில் எங்கெங்கெல்லாம் வந்து நம்ம அனலாகாக சிக்னலை ட்ரான்ஸ்மிட் பண்ணுறோமோ அது எல்லாமே அனலாக் டேட்டா சிஸ்டம்ஸ், டேட்டா அக்விசிஷன் சிஸ்டம்ஸ். டிஜிட்டலில் நீங்கள் பெர்ஃபார்ம் பண்ணுறது எல்லாமே டிஜிட்டல் டேட்டா அக்விசிஷன் சிஸ்டம்ஸ். இதுக்குன்னு ஸ்பெசிஃபிக்காக இதுதான் வந்து அப்படின்னு நம்ம சொல்ல முடியாது. ஆல் திங்ஸ் கவர்டு together, that's all, right? It's over. So with this, your measurement syllabus also completely over. In analog, I told you there is a small portion yet to complete, that will be a characteristics of the operation amplifier. That things will be uploaded by today evening, right? There are no more things to cover, it is over, right? And I left one more small portion, that is our what I told you, canonical form, right, in matrix, right? Okay, fine. Let me discuss and the portion மட்டும் நம்ம தனியா வந்து I will upload some 20 minutes lecture, you can just watch it later, right? With this, your syllabus is completely over, right? If time permits in future, if I'll get any time, then I will bring some external faculties to handle microprocessor. Right now it is not possible, right? Because I have to talk with them. If they are free, then I will try to, you please complete first, நீங்க இதை ஃபுல்லாக முடிச்சிருங்க, and then possibility இருந்தது அப்படின்னா I will bring, otherwise I will give my support. Some materials வந்து கலெக்ட் பண்ணி I will give for microprocessors. You can just make ஒரு சும்மா ஒரு ஹிண்ட்ஸ் மாதிரி என்னென்ன டேட்டாஸ் இருக்குது, அதுக்குள்ளே நம்ம என்னென்ன பண்ணுறோம், அது மாதிரி அதில் ஆப்ரேஷன்ஸ்லாம் எப்படி பண்ணுறோம், அதை மட்டும் just you have to understand the layouts. That is enough, right? Basics of 8085 and 8086. Okay, with this let's wind up. If you have any another issues, you can ask in our group. Thank you all.